Researchers may have found a way to inject information directly into the brain.I. In a new study, a team of neuroscientists has shown that delivering tiny electrical currents to the premotor cortex of monkeys can essentially provide instructions that guide their movements. While the research is still in the early stages, the experts say this could pave the way for treatments to help people who have lost some brain function after a stroke or injury. The researchers used a different point of stimulation in the brain for each of the 4 lights and movements. Then, the lights were taken away. After doing this, the team found that the monkeys were able to carry out the correct movements based only on the microstimulation. Previous research has shown that stimulation can trigger a response in the arms and hands. Schieber, a physician and researcher at the University of Rochester. What we are showing here is that you don't have to be in a sensory receiving area in order for the subject to have an experience that they can identify. In the new study, published to the journal Neuron, the team trained 2 rhesus monkeys to execute tasks based on visual instructions on movement. As the lights were switched on, the team also administered low levels of electrical stimulation to the monkey's premotor cortex. The researchers used a different point of stimulation in the brain for each of the 4 lights and movements. The monkeys can't tell us what they are feeling, so training them to associate the microstimulation with the movement is the way we are able to confirm that they have felt an urge or had some kind of experience, Schieber says. Previous research has shown that stimulation can trigger a response in the arms and hands. To ensure that this wasn't the case in the new experiments, the researchers changed the location assignment of the electrodes and retrained the monkeys with the lights. And they found that the monkeys were able to associate the different areas of stimulation with the reassigned movements. The study could pave the way for better brain-computer interfaces in neuroprosthetics, the team says. Most of the work in the development of brain-computer interfaces has focused primarily on the sensory area of the brain, said lead author Kevin A. Mazurek, a postdoctoral fellow in Schieber's lab. But that confines where in the brain you're able to deliver the information. In the study, we show you can expand the neural real estate that can be targeted with therapies. This could be very important for people who have lost function in areas of their brain due to stroke, injury, or other disease. We can potentially bypass the damaged part of the brain, where connections have been lost, and deliver information to an intact part of the brain. Moving forward, the researchers say the technique could be tried in humans. When you stimulate the somatosensory or visual cortex directly, the subject typically feels something on their skin or sees something in their vision, Schieber says.